Hello friends, welcome to Code Crash Coding. In this video, we are going to learn about Java parallel array sorting, which is one of the important feature of Java 8. So Java provides a new additional feature in array class, which is used to sort array elements parallel. So we already had the method called sort to sort the array elements. But in the sort method, it was sorting the elements in a single threaded environment. Like it will sort the elements in one execution only. But using the parallel sorting, what it will do, it will sort using multiple threads. So it will use multiple threads to sort parts of an array simultaneously, improving performance on large data sets. So when we have the larger values in the arrays, so in that case, we can go with parallel sorting. Because in the parallel sorting, it will be executing the sorting with the help of multi-threaded environment. So the traditional sorting method was sort method, but from Java 8, we have a parallel sort method. So how this parallel sorting works? So first thing is it will divide the array into sub-arrays. So let's say you have 100 elements in the array. So it will divide it. So if it divides into sub-arrays, let's say it divides into 4 sub-arrays, then in each sub-array there will be 25 elements, right? After that it will sort. So each sub-array is sorted independently in parallel. So all the sub-arrays will be sorted independently. After sorting all the subarrays, the third step is to merge. The sorted subarrays are merged to form the final sorted array. So first thing, it will divide it into subarrays, then it will sort each subarray independently. And after that, it will merge all the arrays to form the final sorted array. So what is the benefit that we are getting here by using the parallel sorting? So it utilizes multiple CPU cores to speed up the sorting process. Now let me show you in the demo. So here I have an array of integer data type. So I have here a value 60, 70, 20 and 15. So these are not in the natural ordering, right? Then we are using a traditional method called sort. So and here we need to say arrays.sort and then we need to pass our array which is ARR and then we are printing the array here. So what will be the output in this case? We will get the sorting here. So I get the values as 15, 20, 60, 70. So this is our natural ordering which is ascending order here. Now, instead of using sort, we can make use of parallel sort. As we have less data here, so it will have a less impact, right? But when we have larger values, then it will reduce the timing of sorting. So instead of using the traditional sort method, in that case, we can make use of parallel sort. So I can say here arrays dot parallel sort. This is a method here, and here I need to pass the array. And after that, the same for loop here that will be used to print the elements. So if I run this code now, so we will get the same output, which is our natural ordering 50, 20, 60 and 70. So this is a method to sort the array in a multi-threaded environment or using a parallel sorting method. So here we can see more examples. Here we have taken a array of double data type and then we are sorting it using a parallel sort. Also this can be done on the string arrays. So if you have a string data type, then you can also sort the array using a parallel sort method in a Java 8. Now another thing we can do with the parallel sort method. So we can pass the start and end index here. So let's say you have this array of integer data type. So inside this parallel sort method, you can pass your array and after that you can provide the start index and end index. So what it will do, it will sort only the data for those particular index. So the start index or the first index is inclusive. So when you provide here a 0, it will start from the 0 index position. At the end index is exclusive. Means if you are saying here 4, so till 3 it will sort. So it will start from 0, 0, 1, 2, 3. So in that case only these 4 elements will be sorted. Other elements will be remaining same. Now let's see this in our example. So here let's add more values. So I will say here 100, 68, 56, 4, 10. So these are the random values that I have added in my array. Now here in the parallel sort, what I need to do, I need to provide the start index and end index. Before that, let me run this code. So here I'm getting the sorting of all the elements that we have provided here, 4, 10, 15, 20. So entire array is being sorted. But I don't want the entire array to be sorted. I just want array to be sorted for these 4 elements. So it will start from the 0th index position. So I will say a 0 and I want till 15. So this is basically 4th element, right? But the index position will be 3 for it. So I will say a 4. So when I say a 4, so it will sort from 0, 1, 2 and 3 because this is exclusive, right? So when I say a 4, so till array index position 3 it will be sorting. So array index position is still 3, it means 15, 4th element, right? Now if I run this code, let's observe the difference here. So see, we are sorting these 4 elements only now. So first element we are getting here is 15, then 20, then 60, then 17, and all the elements are same. That means they are not changed. After that we are 100, 68, 56, 4 and 10. So this is one of the use of parallel sorting. Also what we can do, you can provide any index position here. So let's say I want to start from third. So the third index position, so 0, 1, 2, 3. So now it will start from 15 and let's say I want to continue till 7 here. So seventh index position. So 0, 1, 2, 3, 4, 5, 6, 7. So it will sort these elements 1500, 68 and 56. So if I run this code now, so see the first 3 elements will be same 60, 70, 20. After that it will be a sorting. So it will say 15, then 56, then 68, then 100 and 4 and 10 will be remaining as same because that we are not sorting. We have provided a start index and end index. So that is a use of passing start and end index in your array.